I'm sure you've seen the periodic table, but here's the surprise. It's not just a list of elements, it's a map of how electrons behave. Every row and every pattern on the table comes from electrons acting like blurry waves, not little particles flying around. If you zoom in close enough, the whole table turns into fuzzy shapes, energy levels, and electron clouds that don't act like classical matter. This is where quantum chemistry takes over. It uses strange rules to figure out how the world works, starting from the tiniest pieces of matter. It tells us about bond strengths between atoms and molecules, about valence electrons, which determine how atoms bond, and how easily electrons can move from one atom to another. It even tells us why gold looks yellow, all predicted before a single experiment happens. Why does lithium give up an electron so easily, while beryllium holds on tight? It all comes down to how their electrons are arranged. Quantum chemistry answers both questions with the same idea: electron configuration. Those repeating patterns on the table, that's electrons filling quantum shells. Those larger sections called blocks, they're orbital shapes carved into the layout. Because electrons in different orbitals behave differently, each block tends to produce elements with similar traits. For example, reactive metals or nonmetals, gases or radioactive elements. The table isn't a chart. It's a fingerprint of the quantum world, a snapshot of how electrons arrange themselves. So the next time you look at the periodic table, remember, you're not just seeing chemistry. You're seeing the hidden quantum code that builds every atom, every molecule, and everything we're still trying to understand about the universe.